Hello and welcome everyone. In this video we'll be discussing measures of dispersion for ungrouped data. There are several measures of dispersion for a given data, but under this video we will see three of them. First of all, what means dispersion? Dispersion describes the spread of data around a central value. Those central values are mean, median and mode. So for this lesson we will see three of measures of dispersion: range, variance and standard deviation. Let us see one by one. What's range? Range means the difference between the highest and the lowest value. Let us state the formula for range. The first point, it's range. We say it already. Range is equal to highest value minus lowest value. From the given data, we need to observe which one is the highest and which one is the lowest, and then we'll take the difference. That's going to be the range. Maximum minus minimum, we can see the difference. For example, let us say some example. The first example for today, as you see here, it says the age of 6 students are given: 24, 20, 18, 13, 16 and 15. What is the range? It says. So first, which one is the highest value here? It is 24, and the smallest one will be 13. Therefore the range will be 24 minus 13, which is 11. Then let's add one more example. The second example here, the data are given in table form. It doesn't matter, we don't have to worry about that. We need to observe from the value which one is the highest and which one is the lowest. The highest here it is 18, and the lowest one it is visible, which is 2. Therefore the range will be, as usual, the largest, which is 18, minus the smallest, which is 2, which is equal to 16. Done. So from the measures of dispersion, from the three, range is simpler one and it is straightforward. For any data it can be calculated, except for qualitative data. In case of quantitative data, because it is number, we can take the difference between the largest and the smallest. Let's continue to the second and the third measures of dispersion. Those are variance and standard deviation. They are mostly related. One is dependent on the other, and at the same time somehow longer process. Let's continue. The second and the third measures of dispersion for this video, for this specific lesson, it is variance and standard deviation. What's variance? As you see here, it's defined variance. Variance is denoted by sigma square. It is defined as the mean of what? Square deviation. First of all, you need to be clear what means deviation. Deviation means the difference between each data and the mean. You need to take each data minus the mean, then square it. After squaring each of them, you are going to take the average of it. The average means the mean. You need to add them all, then divide by the total frequency. That's going to be variance. There are steps to find variance. What are the steps? First, you need to find the mean, as you see here. And the second step, find the deviation. Each value minus the mean we need to calculate. And the third step, square it. Okay, the step 2 will be square. And then find the average. That's going to be the variance. When you come to standard deviation is very simple to define. Once we have variance, standard deviation means the square root of variance. Done. Let us see example, and the example clarify much better. The first example here, it says find the variance and standard deviation for the following data. The data are 3, 5, 8, 11 and 13. Very simple data. There is no frequency. Each data appears just once. Therefore, let's write the value of each data in vertically. Those are 3, 5, 8, 11 and 13. Okay, so that each value are written vertically, as you see: 3, 5, 8, 11 and 13. The sum of all the data become 14. So at this point we can find the mean. Very simple. Mean is equal to total sum divided by total number of elements, which is 40 over 5 data we do have, which is going to be 8. This is the mean. Therefore, we need to find the deviation now. The deviation means, as you see, each value minus the mean. That means 3 minus 8, which will be negative 5. And again 5 minus 8 will be negative 3. And 8 minus 8, 0. And then 3. And then 5. Then square it. This is deviation. Then the deviation square has to be calculated. P minus x bar, the whole square. When you square, negative 5 square is 25. The negative 3 square is 9. And 0 square 0. And then 9. And then 25. Then find the sum of all these. When you add it, 25, 25, 50. And 9, 9, 18. Together 68. Once we have everything here, we can find now the variance. The variance sigma square is equal to the sum of v minus x bar, the whole square, summation of the total frequency. Actually, the total frequency is 5 data only, because as we said before, each of the data appear just once. Therefore, it will be 68 over 5, which is 12.6 when you divide it. This is variance. But the standard deviation is the same as the square root of variance square. The square root of variance, which is square root of 12.6. Done. So what makes our process easier here, when you are like writing vertically, it will be clear and the step will be not complicated. Let's go to the next example. When you go to the next example, again here it says find the variance and standard deviation of the following population whose distribution is given in the table below. The values are 2, 3, 5, 6 and 8, and each of the value they have their own corresponding frequency. The 2 appears 3 times, the 3 appears 4 times. That's the pattern, as you see. Therefore, let's write vertically like that of the previous one. Here it is, so that the data are written vertically. As you see here, each of the data are 2, 3, 5, 6 and 8. The one which is written horizontally here in the first row, it's written as a first column. And then the frequencies are, as you see here, 3, 4, 4, 5, 4. Okay, then the total frequency, we need it, because when we are trying to find the mean, divide by total frequency. Total sum divided by total frequency. Then the total sum of the data, first of all, every data has to be multiplied with the corresponding frequency. So 2 times 3 will be 6. This is the value times the frequency, because 2 appears just how many times? 3 times. So adding 2 plus 2 plus 2, or adding 3 times, it means 2 times 3. The same manner, 3 times 4, 5 times 4, and 6 times 5, and 8 times 4. These are the value, each value with the corresponding frequency multiplied, and then add it. Therefore, at this point, we can find the mean. The mean is equal to the mean is equal to the total sum is 100 divide total frequency, which is 20, which will be 5. Okay, we have the mean now. Once we have the mean, let's find the deviation now. Each value will be taken, the difference between each value and the mean. So 2 minus 5 will be negative 3, and 3 minus 5 negative 2, and 5 minus 5 0, and 6 minus 5 1, and 8 minus 5 will be 3. Then square it. Okay, the deviation square has to be calculated. 9, 4, 0, 1 and again 9. Then multiply with the corresponding frequency. 3 times 9 will be 27, and 4 times 4 is 16, and 0 times whatever 0, and then 5, and then 36. Okay, let's find the sum here. We need it, because the variance means the average of the deviation square. So that let's add it. When you add it, it's going to be 32, 84. Yeah, it's going to be 84. Therefore, the variance will be, okay, we will take this sum, then divide by the total frequency. It's going to be 84 over 20, which will be 4.2. Done. And the standard deviation, it will be the square root of it, 4.2. Done. So this is it. So the main process, okay, you need to go step by step. What we see here in the steps to find variance in the standard deviation, it has to be clear. Here we already discussed. First we need to find the mean, and then the deviation, then square it. But the data, if it has, each data, if it has its own frequency, you need to multiply with the corresponding frequency. Then take the total sum, divide by the total frequency, that's going to be the variance. Finally, the standard deviation. These are some examples. But remember, there are some rules here, or properties of variance and standard deviation. The first property, if a constant number is added to each value of a given data, then the new variance and the new standard deviation will be the same as the old. What does that mean? For example, in this data, if you add any number, like for example, if you add like +5, +5, +5 in each data, okay, if you add the same number, the new variance, okay, after adding constant in each value, if you try to calculate the variance in the standard deviation, no change, as it is, it will be the same as old, it says. So that is rule number 1. Don't forget, adding a constant, okay, adding constant in each value doesn't change the variance in the standard deviation. The second property, if each values are multiplied by a constant, then the new variance and the new standard deviation will be changed. How? The new variance will be c squared, it says, c squared times old variance. Here it is. And the new standard deviation will be absolute value of c times the old variance. What does that mean? Instead of adding here, what if you multiply each of the data by 5, let's say? If you multiply by 5, okay, times 5, times 5, times 5, each of them. If it is, therefore, the new variance will be 4.2 times 5 squared, according to the rule. The new variance will be the old variance times the square of the constant, what's multiplied. And the new standard deviation will be the old variance, 4.2 times absolute value of 5. Why we say absolute value? Because we cannot take negative. If you multiply by negative number each value, finally the new standard deviation will be the positive of it. You will take the positive of the multiplier, the constant, 10 times the old variance. These are some of the properties of variance and standard deviation. Try to memorize those properties and try to see my example. Using my example, I need you to do these two exercises. These two exercises are really helpful. If you practice with this exercise, it's going to be clear for you. If you have mistakes at the middle or at some point, that means you need to clear out again. Thank you for watching. Don't forget to subscribe and share.